Okay, so this is on page 6 of the class handout, um, and before I get into filling in this statement, I'm going to just address practice problem number 2 that you guys had worked on and did well. And to tie it because it'll be tied to this piece. So in problem number 2, you guys were given this function here, and then the problem's already telling you the intermediate value theorem applied to f on the closed interval from 24 to 28 guarantees which of these solutions. So it's already telling you that the intermediate value theorem applies, so you don't need to check for continuity, but you do have to check whether you do have to figure out which of these y values actually is in between the y values corresponding to 24 and 28. So the point being that you can use the intermediate value theorem not for just finding where the roots are, but you can also use it to just identify if a function can equal to a specific y value other than 0. So for this problem, most people went into the process and just found f of 24, and when you plug in f of 24, you get approximately 10.06, and then if you find f of 28, let's see, 28, you should get 66.193. Okay, so our y values, we're trying to decide that the intermediate value theorem says it will work here. It has to be between 10.806 to 66.193. So 0 is not between those two numbers. Therefore, the intermediate value theorem can't guarantee us that the function will go through 0. 9.090 also is not between these two numbers. So again, you can't guarantee us that this is actually going to be equal to it. Or that the function passes through this value on this interval. And most people had selected C, 12.235, because 12 is between these two numbers. Okay, so the answer choice is C, and then obviously D is outside of the range of y values, therefore we can't say that the intermediate value guarantees us that the function will go through that number. Okay, so tying this back to the statements here, so this is the actual intermediate value theorem, just generalized for any y value, not just equal to 0. So you guys should have filled in if a function f of x is continuous on the closed interval a, b, and remember that a and b refers to the range of x values, and the y value d. Okay, so d is in place of 0. We're going to say it's just any number d. The y value d is between f of a and f of b. And remember that these are the y values corresponding to these x values. Then it is guaranteed that there exists at least an x value c, right? Some c that's between a and b, such that f of c equals to d, meaning there's for some x value, that x value will equal to the value of d. So that's the intermediate value theorem generalized for any value of y on any given x interval a, b.